Hello, is my voice audible? Okay, thank you. Hello, all. Welcome to the third section of the problem solving. I'm Gitanjali. I will help you in uh, I will help you in solving some of the problems which will help you to understand the concept better that were told in the class. So let's wait for some time so that some people also can join. Let's wait for 3 minutes, then we will start. Okay. Okay, let's start the session. Let me take a short quiz. So, everyone can see the screen, right? I think everyone can see the screen. So, this is one of the shortest quiz. So it is given phi and psi are the two quantum mechanical states of a system. So now it's given that uh, it's given this the inner product of psi with 5 with psi is 3i plus 5. Then what is the value of uh, this inner product? So let me explain the questions once again. So now it is given psi phi and psi are the two quantum mechanical states of a system. So if phi and psi inner product is 3i plus 5, then what is the value of inner product of psi with phi? Anyone wants to answer this question? You can raise your hand and then I will unmute you. Go through the questions once again. Then let me know whoever wants to answer the question. Otherwise, uh, I will tell the answer, how to solve it. Just apply the properties of a linear vector space. Then I think you can answer this question. Okay, let me explain the answer then. So it's given psi with is 3i plus 5. Then it is asking about psi inner product of psi with phi. But you have known that one of the properties of a linear vector space, that is if the inner product of psi it is given, then the other inner product is nothing but the complex conjugate of the previous one. So this is one of the property of a linear vector space. So now it is given that uh, this one is given. So and you want to find out what will be the value of psi with phi. So it is nothing but psi with phi is nothing but the complex conjugate of this. Now it is given 3i plus 5. If you want to take the complex conjugate, just replace the item with minus item, and the real numbers, the complex conjugate will be same. So it will be minus 3i plus 5. So this is the answer. It is based on one of the property of a linear vector space. So, if in a question it is given like phi is given to you and psi is given to you, and you calculated the value of phi with psi. But now in that same question, if it is asking about what will be the value of psi with phi, then you don't need to calculate the whole procedure. Like don't need to do the whole procedure. You just take the what is the value you are getting for this and take the complex conjugate of this. So this will uh, easy your calculation. Like psi, if you know this, then you can simply calculate the value of this inner product by taking the complex conjugate of the one that is given to you. I think this is clear to everyone. So let me recall you some of the before starting the problems. Let me recall you some of the concept that is related to today's problem solving section. So okay, so there are two formalism that is used to describe the systems in quantum mechanics. One is the matrix mechanics, which was given by Heisenberg, and other one is the wave mechanics, which was given by Schrodinger's. So these are two formalism. So now the most common that is used today is the Dirac bracket notation, because this is the single formalism which contains the both concepts like matrix. You can write the bracket notation in matrix mechanics, and also you can use bracket notation to solve the problem in wave mechanics. So this was one of the concept which was given by Dirac, and how he gave the concept, he utilized some of the properties of linear vector space uh, to derive this concept. So, in Dirac concept bracket notation, what we do if we have a state, let's say psi. We have a state, then we in Dirac notation we represent psi as the Kate vector psi. This is the Kate notation. So this is written here. If psi represent one of the quantum state of a system, then in Dirac notation it is represented by psi. So what is the psi? Psi is it's the element of a Hilbert space. Like in our daily life, we use a real space, which is if you take the Cartesian coordinate, then it is made up of x, y, and z. But in quantum mechanics, we use Hilbert space. So Hilbert space is nothing but it is similar to a real space, but it has some additional properties like it consists of the same, consists of vectors, and it consists of scalar ABC. And two of the main important properties of a Hilbert space is it's a linear vector space. So it is satisfies the property that the linear vector space has, like it is close under addition and multiplication. Like if I want to give you example, then closed means if psi is the element which is element of a Hilbert space, and if let's say phi is also belongs to this Hilbert space H, then if we add this value, then this also an element of the Hilbert space. And similar to multiplication, if we multiply to this, then we will get a element which is also belongs to this Hilbert space. Like that, close, and we have also commutative property like psi plus phi must be equal to phi plus psi. And associative, like psi, if we have three vectors psi, phi, and chi, then if we first add these two vector, then add this one, then it uh, is similar to adding the second and third vector first, then adding the first vector. So this is the associative property, and the other one is the existence of a zero vector. Like so that if we add this zero vector to this quantum mechanical state, we get the same vector psi, and the inverse vector which will give a null vector like psi minus psi will give a null vector 0. So like that, one of the other properties is scalar product, which is given by this equation psi phi equal to phi psi star. And this one I have used in the short quiz to solve the problem. So, okay, in so Dirac notation, what we do is we represent a state psi in terms of the basis vector. Like the basis vector can be represented in various forms. So if phi I is the orthonormal basis, then we can represent this psi in terms of this. Like if you don't have the orthonormal basis, then you must do the Gram-Schmidt orthonormalization to find out the vector, find out the orthonormal basis phi. So here the Ci are the coefficient of the vector, uh, coefficient of the this quantum mechanical state in various orthonormal basis direction. So now, similar to this inner product, if we want to take the inner product of this gate vector, then we defined another vector which is bra psi. So this bra terms arises due to the inner product of psi. So now this in this bra vector is nothing but the dual conjugate of this vector psi. So now if we want to take the inner product of psi, this vector, then we can write it in this term. Like in our real space, we take normally if a vector A is given, let's say ik plus 2j cap plus 3k cap, and B is given, which is 2i cap plus 4j cap plus 5k cap. If these two are given, then to take the inner product, we simply take A dot B, which is given by just the 2 plus 4 plus 5. Similar to this formalism that is familiar to us. So we in quantum mechanics, we what we do, we take the inner product, we represent the inner product in this term, like psi with psi. This is the inner product uh, in the in bracket notation. Now, similarly, we have seen the bracket notation can be used in both, like in wave mechanics as well as in matrix mechanics. So these are the two formalism that is used to understand the problems better. Like in some cases, we can understand it using the wave mechanics, and in some cases, we can understand it if we use the matrix mechanics. So according to your problem, you can use any of this formalism. So now in matrix form, then how you can write a kth vector in matrix form? So normally we'd start with, let's say we represent the kth vector as a column vector. So normally we represent a kth vector in terms of a column vector, which is let's say it has coefficients a1, a2, and a3. Now, if you want to represent this kth vector in terms of a bra vector, then you simply take the row vector of this column vector. So now if you have, let's say you have a kth vector psi in terms of a1, a2, a3, then in bra vector, this simply becomes a row vector, and the constant becomes the complex conjugate of the initial constant, like a2, a3. So it will become a1 star, a2 star, and a3 star. So now if you take the inner product, then it is nothing but the product of a row vector and the product of a column vector. So now if you multiply it, then it will simply becomes a1 star, a2 star A, and a3 star A. So this is nothing but this. So now you can see that the size equal to this. This is nothing but that this is similar to what we use in the in daily for daily in daily practice. So it is similar to the dot product that we use in the Euclidean space. So now if you want to, like similar to if a vector is given and you want to find out what is the magnitude of the vector, then you simply take the what you do, you simply take the square root of a square. Similar to that, in quantum mechanics, instead of magnitude, we define it as a norm of psi. So norm of psi is given by it is nothing but is given by square root of this inner product. Okay. So this is for the quantum mechanical state. Now, if you want to represent a operator like the position operator, the momentum operator, or the Hamiltonian operator, then you can also write it in terms of the matrix form, which is given by this. A is A1, A11, A12, A13, A1n. This is the matrix representation of a operator in the quantum mechanics. So I think this is some of the basics which I want to tell before starting the session. So let's start the section now. Let's solve some of the problems. So please go through the properties in detail, so that in most of the time, if simply by looking at the property, you can understand the problems and the situation better. So let's see the first question. So everyone, please read the question at least once. So it is asking, check whether the following vectors are linearly dependent or not. These are the vectors psi1, psi2, and psi3. So I will read the question again. So it is asking about check whether the following vectors are linearly dependent or not. So, so it is asking three vectors are given, and it is asking about whether they are linearly dependent or not. So you can see the vectors, the kth vectors are represented in terms of the column vector. Like psi1 is 5, 3, 4. Let me write the vectors. It is 5, 3, 4. And the next vector is 1, 2, 3, and the next one is 7, 7, 10. And it is asking about whether psi 1, psi 2, and psi 3 are they linearly dependent. So if you want to check the linearly dependent property of uh, a set of vectors, then first what you have to do is first check whether um, there are two ways you can check whether they are linearly dependent or not. First quick check is check whether one of the vector can be represented in if three vectors are given, then check whether one of the vector can be written as a linear combination of other vectors. So one of the vectors can be written as some linear combination of other vectors. Like here, what is given to you? Psi 1, psi 2, and psi 3. So first check whether you can write whether you are able to write one of the vector, let's say psi 2, in terms of psi 1, some linear combination of psi 1 and psi 3. And there will be some constant a and b here. So first check this one. If you are not able to check this one, then the normal procedure to check is take the linear combination of these three vectors. Let's say a1 psi 1 plus a2 psi 2 plus a3 psi 3. Take the linear combination of these three vectors and equate it to 0. Now, uh, if psi 1, psi 2, and psi 3 are linearly independent, then you will see that this condition is satisfied when a1, a2, a3 equal to 0. So if you are getting this condition, then you can tell that this psi 1, psi 2, and psi 3 are these are linearly independent. And if instead of this condition you are getting that even if in some of the situation this some non-zero values of a1, a2, a3, if some for some non-zero values of a1, a2, a3, if you are getting this condition, then you can tell that these three vectors are linearly dependent. So these are the two ways in which you can check whether the function is linearly dependent or not. So let's solve the problem. Um, so given psi 1 is 534, psi 2 is 1, 2, 3, and the other vector is 7, 7, 10. So first, for quick check, you can check whether you are able to write uh, any one of the vector in terms of the other vector. Now you can see here the psi 3. Psi 3 is 7, 7, 10. So you can write 7, 7, 10 is some 5, 3, 4 plus 2, 4, 6. This one you can write, right? So this means that 534 is psi nothing but psi 1. And 246, you can write it as 2 times 1, 2, 3. So psi 1 is 2 times of psi 2. So here you are saying that you can write psi 3 as psi 1 plus 2 times of psi 2. So this means that these three vectors are linearly dependent. They are not linearly independent. So this is one of the quick way that you can check whether these vectors are linearly dependent or not. So or other method is the normal the method that we use like write psi 1 psi 2 psi 3 in linear combination of each other and equate it to 0. Now check whether this condition is satisfied only when a1 equal to a2 equal to a3 equal to 0. If this condition it is satisfied only when this is satisfied, then in that case you can tell they are linearly independent. Let's check then. So first one is a1 is 5, 3, 4 plus a2 1, 2, 3 plus a3 7, 7, 10, and you want to equate it to 0, 0, 0. It is the matrix form. So instead of writing a single zero, you can write 3 zeros. So now simplify it. So it will be what? It will be 5a1 plus a2 plus 7a3. The second one will be 3a1 plus 2a2 plus 7a3. In the third one, 4a1 plus 3a2 plus 10a3. This will be 0, 0, 0. So now you can simply write it as you will get three equation a2 plus 7a3 to 0. Next one is 3a1 plus 2a2 plus 7a3 equal to 0. And the third one is 4a1 plus 3a2 10a3 equal to 0. Now you are getting three equation and you have three unknowns. A1, A2, A3. I think everyone can solve it using the method of elimination. So you can solve, you just eliminate one of the coefficient and find out the relation between them. So if you solve it, then you will get the final form as A1 equal to minus of A3, and the other one is A2 equal to minus of 2A3. So now you are saying that uh, the coefficients are related by this. So this means if I take some non-zero value of A1, A2, A3 other than 0, then in that case also this condition will be satisfied. Like if I take let's say a3 equal to 1 and a1 must be equal to minus of a3, so it will be minus 1, and a2 will be equal to minus of 2a3 minus 2. So if I take this combination, then in that case also this relation in that case also for non-zero values of a1 a2 a3, this will give 0. So this means these vectors are linearly dependent. So this is all. So you can solve it in two ways, like I said. First, check whether you are able to write one of the ket vector in terms of the linear combination of other two vectors, and the other one is to check whether take this linear combination a1 psi1 a2 psi2 a3 psi3 and check whether this condition is satisfied only when a1 a2 a3 equal to 0. If it is if this condition is satisfied for non-zero values of a1 a2 a3, then in that case these are linearly dependent. So let's see the second question. This is similar to the first one. So that you can understand it better, I have taken two examples. So read the question at least once. Everyone read the question. Okay. So it is asking about check whether the following sets of function are linearly independent or dependent on the real x-axis. So the first one is given is f of x equal to 4, g of x equal to x square, and h of x equal to e to the power 2x. So by simply looking at it, you can tell that you can't write any one function as a linear combination of the other two function. So you, in that case, you can say that these three vectors are linearly independent. Other way is take the linear combination of these vectors a1 psi1 a2 g of x plus a3 h of x and equate it to 0. So first one will be 4a1 plus a2 x square plus a3 e to the power 2x. This will be 0. Now you are seeing that the coefficients are different. Like, sorry, the functions are different. Here it is 4, it is x square, and this is e to the power 2x. So this is only 0 whenever the a1 is 0. Similarly, the a2 is also 0 and a3 equal to 0. So this means this set of vectors are linearly independent. These are linearly independent. So let's see the second question B. What is given? F of x equal to x, g of x equal to 5 of x, and h of x equal to x square. So this means now by simply looking at Ankit. Okay, let me unmute you. Tell Ankit. You have any?
Am I audible?
You are audible. Okay.
Ma'am, I was late in the session, so can you please just explain me how is A1, A2, and A3 are zero?
For which question? This one?
Yes, ma'am. Second question, first part.
Okay, first one, right? So,
Yes, ma'am.
okay. So this is, look, there are three functions given. One is f of x, g of x, and h of x. One is, for first, it is 4, it is a constant value. And the second, it is x square. And the third one is e to the power 2x. Now, if you look at this function, like 4x square and e to the power 2x, then you cannot write one of this function as a linear combination of other. Like you cannot write 4 as a linear combination of x square e to the power 2x. Similarly, you cannot write x square in terms of 4 and e to the power 2x. And similarly, you can't write e to the power 2x as a linear combination of 4 and x square. You can't write, right? These are completely three different functions. So
Okay,
now,
ma'am.
so now if you simply looking at, you can tell these are linearly independent. So now if you want to check the using the usual method, then you what you have to do, you have to multiply each of this function as with some constant a1, a2, a3. So now if for the final equation is this one, 4a1 plus a2x square plus a3 e to the 2x. Now you can see the right hand side is 0, but the left hand side has some non-zero value like 4a1 plus a2x square. This right hand, sorry, left hand side is non-zero, but right hand side is 0. So this means
Yes,
that
ma'am.
this will be 0 only when the constant vanishes. Like the constant is itself 0.
Mhm.
That
Yes,
is
ma'am.
why if this condition like for these functions, the only possibility is a1 is 0, a2 is 0, and a3 is 0. So that means these functions are linearly independent.
Okay, ma'am.
Uh,
Clear, ma'am. Thank you.
okay. Okay. Now the second one is f of x equal to x, g of x equal to 5x, and h of x is x square. Now, if you say, if you compare f of x and g of x, you can see these are related. Like one is x and other one is 5 times of f of x. So g of x you can write 5 times of, which is 5x. So this means 5 times f of x. So you can also write it as 5 of x plus 1 minute. 5 times f of x plus 0 times h of x. So here you are saying that you can write one of this function as a linear combination of other function. So this means that this three functions are not linearly independent. Okay, this is one of the quick way in which you can check, or other ways the simple one, like take the linear combination of these three vectors a3 h of x, which is equal to 0. So now put the value of these functions. G of x is 5 times of x, and the third one is
Excuse me,
it.
ma'am.
Tell.
Ma'am, can we write uh, gx is equal to 5x is equal to 5 times hx upon fx?
Let me write what you are saying. G of x equal to
5 times hx upon fx by dividing hx and fx.
5 times 5
hx
times
upon hx upon
hx.
fx. So it will be equal to 5x.
Okay, that you also can write like
And
5x
in this way,
square
it
by
is gx is
uh,
dependent on other two functions.
uh,
So can we write in this way also?
you can write.
Okay.
So okay. Um, so this is equal to 0. Now you can write a1. So factor out the x term, common term, x plus a3x square equal to 0. So this means that here there is a coefficient of x and there is a coefficient of a3, and in right hand side there is 0. So this means that this individual term will be 0. So that means a1 plus 5a2 equal to 0 and a3 equal to 0. One you are getting a3 is 0, but the other one is a1 equal to minus of 5 times a2. So this indicate that uh, if you take some non-zero value of a2 and a1, then in that case also this equation is satisfied. So this means that these three functions are linearly dependent. They are not linearly independent. You can check by taking one of the uh, like one of the value of a2. Let's say a2 is 1 and a1 is by, but use this relation. You can't take arbitrary value, but use this equation, then A1 will be -5 and A3 is 0. So if you put A2 equal to 1 in this equation, A2 is 1 and A1 is -5. So it is -5x. So g of x is 5x, A2 is 1, so it is 5x and A3 is 0. So this itself give 0 for non-zero value of A1, A2 and A3. So that's why you are telling, we are saying that these three vectors are linearly dependent. I think this one is also clear. In the third one, see, let's solve the third equation. Third question, f of x equal to 2 plus x square, g of x equal to 3 minus x, 4x cube, and h of x equal to 2x plus 3x square minus 8x cube. So now see that the third one. The third one, if you see, they have h of x as the coefficient of x square and x cube. And the f of x has one term which is x square, and g of x has both x and x cube. And this says both the term x square and x cube. This is x and x cube. And this is only x square. So this means that you can write this one in terms of this one, this two. Like if the the final one is, I think, h of x, here 8 is there. So it must be 2 times of g of x and 8, let's say 2x plus 3x square minus 8x cube. So you are saying there is a 8 here and this is minus. So here xq is here. So that means you can write in terms of minus of 2 times of g of x, and f of x is x square. Here x square, the coefficient is 1 in this case, but you are saying there is 3 here. So this means this is 3 times of f of x. So this is the complete expression. So you're saying that you can write h of x in terms of f of x and g of x. So you can tell that these three vectors are linearly dependent. Now the normal one, let me solve using the normal procedure. So for that you have to take a1 f of x plus a2 g of x, a3 h of x, which is equal to 0. So if you are not able to check whether the linear combination is happening or not, then check this condition. Okay. So f of x is 2 plus x square plus a2, g of x is 3 minus x plus 4x plus a3 is 2x plus 3x square minus x cube equal to 0. So that means, so first collect the term which have equal powers of x. Like collect the term x, collect the terms where the power of x is 1 or 2 or 3. So if I do that, it will be a1 plus 3a2. This is no power of x, let x to a 0, plus now let's take the term of x. It will be 2a3 minus 3. Sorry, it is. So it will be A2. I take in these two values. 2A3 plus A3 x plus. Let's see the term x square. A1 plus 3A3 x square plus x cube will be 4A2 minus 8A3. X cube equal to 0. So similarly, what I did in the previous questions, you can equate this coefficient to 0 because in the right hand side there is 0 is here. So that means the coefficient of the powers of x must be individually 0. That means 2A1 plus 3A2 equal to 0. 2A3 minus A2 equal to 0. A1 plus 3A3 equal to 0. And 4A2 minus 8A3 equal to 0. So now you're seeing that these coefficients are related to each other. That means if you take some non-zero values of A1, A2 and A3, then you will still see that this condition is satisfied. So this means these vectors are linearly dependent. So these vectors are linearly dependent. So these are all about the linearly dependent or linearly independent. I think everyone understand the problem. Then let me solve the next problem. Everyone read the question once. Go through the question. So let me read the question for you. Uh, Suppose that phi 1, phi 2 and phi 3. These constitute an orthonormal basis, that is phi 1 phi j inner product is delta ij. So then consider the following kets given in this basis, these two ket vector. Then it is asking about what will be the expression for psi and phi, the bra vector of psi and phi, and what will be the inner product of psi and phi, and so that this property is satisfied. And the other one is asking about what will be the expression for this state. The last one is this. So, okay. So I have tell you that I think in my previous problems I have told you about the bra vectors many times. So now this is given to you, psi. So you want to find out what will be the bra vector of this state. So this is nothing but the dagger of the kate vector psi. I think in one of the problem I have wrote psi star, but in general you can write, if you are taking a matrix method, then you should write it as a dagger, not as a star, but write it as a dagger. So this is nothing but the dagger of the Kate vector psi. So psi is given to you 3i plus phi 1, sorry, 3i phi plus 2 phi 2 plus I phi 3. So now if you want to find out what is the dagger of this, what is the bra vector, then simply replace. So for this, like from, let me write clearly. If you are going from a Kate vector to a bra vector, then you have to just replace this Kate notation with bra notation, and you have to replace any I with minus I, that is, take the complex conjugate of the constants. Okay, so these are the steps you have to follow. If you are wrong at this step, then the answer will be different. So be careful while writing the expression. So psi must be equal to, this is 3i dagger. So if you want to find out the final expression, so this must be equal to, here I is there, so it will become minus 3i. The Kate vector will become a bra vector plus 2 is a real number, so it will be 2 pi 2 plus, here I is there, so it will become minus I phi 3. So the final expression will be minus 3i phi 1 plus 2 phi 2 minus I phi 3. So this is the final expression. So for the second one, I think now everyone can solve it. Second one is 2 phi 1 3 phi 2 plus 5 phi 3. And you want to find out what is the bra vector corresponding to this Kate vector. So take the dagger of this operator, dagger of this Kate vector. So now you are seeing that the constants are real number. So there is no items. So this will be simply 2. The Kate vector will become bra minus 3 phi 2 plus 5. This will be a bra vector phi 3. So these are the final forms. If you want to find out the Kate vector, these steps are crucial because if you are wrong at one of these steps, then the whole answer will be different. Like if you want to find out the expectation value, then if you are wrong at this step, then the answer will be different. So be careful while finding out the bra vector, Kate vector from a given vector. So now you have to, let's see the second question. Second question is asking about compute the inner product of phi with psi. So I think this is simple. So let me write the answer. So psi, this is nothing but the inner product of, you take a bra vector and take the inner product with the Kate vector. So bra vector is here. So take that 3 phi 2 plus 5 pi 3. So while writing the step, be careful uh, of the sign. So psi is this 3i plus 2 plus I. Is 3i phi 1 plus 2 phi 2 plus I phi 3. Now you can just take the product of these two expression. You can, I think this will be 6i phi 1 phi 1 plus 4, 5, 1, 5, 2. Like take this one, multiply with this, then take the second one, multiply with the whole expression. This will be 2y, 5, 1, 5, 3. Similarly, for the second term, it will be 9i, 5, 2, 5, 1 plus uh, will be 6, 5, 2, 5, 2. The last one is minus 3i, 5, 2, 5, 3. And if you take the third term, 5i3, then it will be 15i plus 15i, 5, 3, 5, 1 plus 10, 5, 3, 5, 2 plus 5i, 5, 3, 5, 3. Now, this is the expression you get, but given the question, one of the condition was given that 5, if you see the question, this was given, like the bases are orthonormal. So this means that the cross term will be 0. Like this 5, 1, 1, 2 will be 0. This will be 0. These terms will be 0. So the final one you will get is this term 6i plus minus 6, this one and this one. So the final one will be, and it was given it is orthonormal. That means phi I equal to 1. So I can simply
Excuse me,
write,
ma'am.
tell.
Can you please explain me once again that why have you taken 5 1 5 into 5 5 1 5 2 means 5 I and 5 j all are equal
Why
to
I have
0.
taken 0?
Ma'am. Yes, ma'am.
Okay, this was given to you. Like this expression.
Ma'am, it is given to equal to 8 ij.
No, this is not 8. This is delta,
Oh,
Kronecker delta. So it was given to you is phi I, phi j is delta ij. Sorry, it was looking like 8, but this is delta. So
okay,
that
ma'am.
means it is 1 when I equal to j and 0 when I not equal to j.
Okay, ma'am.
Okay. So this is, so the final term will be 6i from here, 5i from here. So this is 5i plus, there will be minus 6 here, minus 6. So the final expression is 11i minus 6. So this one is done. So now let's go to the next part. It is asking the so that this property is satisfied. This is one of the property I have showed you. That is one of the scalar product property. So now it is asking about uh, uh, to check whether this property is satisfied for this case or not. So for that, uh, we have psi phi, which is 11i minus 6. So we want to find out phi psi. So let me write the expression for psi. So I think the kate vector is, the bra vector is this, not this one. Minus 3i phi plus 2 phi 2 minus I3. So use this and use the kate vector expression for phi. If I use it, then it will come out as 3i phi 1 plus 2 phi 2 minus I phi 3. And the kate vector is 2 phi 1 minus 3, phi 2 plus 5, pi 3. So now just multiply it, and in the previous case you see that the cross terms are 0, like 3 2 is 0, 1 3 is 0. So you just have to take one of the term. You just have to take the terms that is non-zero, like 5 1 5 1. So if I take 5 1 5 1, then it will be 6 I 5 1 5 1 minus 6 5 2 5 2 plus 5 I 5 3 5 3. It is not plus. I think it is. So this is minus. So these all are 1 is given. So it will be minus 11 I minus 6. Now if you compare these two, this one and this one. This is 11I minus 6 and this is minus 11I minus 6. So that means this is nothing but the complex conjugate of the previous one. So psi phi is the complex conjugate of. So this is one of the question I have asked in the short quiz. That is, this is given to you. Then how can you find out the value of this? So just take the complex conjugate of initial one. Then you easily find out what is the answer. Now let's move to the next problem. This one. So here a constant term is given, a equal to 2 plus 3i. Harish, wait 1 minute. Harish, tell, you have question.
मैम असाइनमेंट 2 के क्वेश्चन में प्रॉब्लम है जो
Assignment
अभी
2.
सबमिट किया हम लोगों ने
जो NPTEL के साइट में जो था असाइनमेंट 2, उसमें प्रॉब्लम है.
हाँ वीक 2 हाँ
वीक
उसमें
2
एक
में
क्वेश्चन के क्वेश्चन है
अभी तो मेरे पास क्वेश्चन है, बट मुझे क्वेश्चन का नंबर बोल दो, उसके बाद मैं वो देख के नेक्स्ट वीक में मैं बोल दूंगी आप तुमको. So just tell me the question number. If you recall the question number, you know the question number.
नॉट नाउ मैम
Okay, then let me go through the assignment too. Then I will clarify your doubt in the next session. Okay, is it okay for you?
मैम इस क्लास में नहीं कर सकते हो क्या
Okay, so I have to find out the assignment too. Actually, I don't have the PDF now. So let me check. 1 minute. Actually, I don't have the question now. Let me log into the NPTEL page. Wait. I think the solutions are also available for this two assignment. Have you gone through the solution?
यस मैम आई गॉन थ्रू द सॉल्यूशन बट
Okay. Okay.
आई डाउट
Which question? Okay. Let me log in here then. So it will take some time. Wait for.
Ma'am, question number 5.
Huh? Question number 5.
Yes, yes.
Okay. Let me see the question then. So it's a problem on harmonic oscillator, right?
Yes, ma'am.
Okay. Let me solve in the last page. Hmm. So psi of x is given to you, which is 1 by root 3 psi 0 x plus root over of 2 by 3 psi 2 x. The expectation value of energy is a function of time can be written as. So for that, what you have to do now? You have to first and psi 0 and psi 2 are, this is the ground state and this is the second excited state of the system. So
Yes, ma'am.
okay. First, what you have to do, you have to first find out what is the value of the function at a later time t. So this is nothing but e to power
मैम
minus. हाँ
ये स्टेशनरी स्टेट वेव फंक्शन है, तो
हाँ
जो एनर्जी है वो टाइम t इक्वल टू 0 पे और टाइम t पे उसका जो एक्सपेक्टेशन वैल्यू है वो सेम मिलना चाहिए, राइट?
yes yes हाँ expectation value is independent of time.
यस, तो देन व्हाई वी आर टेकिंग दिस?
Okay, so you are asking why I am taking this one, right?
या
Size 0 and size 0 and psi 2 are the ground state and second excited states energy
मैम
eigenfunction.
सिंस वेव फंक्शन गिवन वेव फंक्शन ऑफ द हार्मोनिक ऑक्सीलेटर, तो we just calculate like probability into energy, right?
Hmm.
If we do this way, then we didn't get any answer which of which of the option. Like
Okay.
in ground state the probability is 1 by 3 and second is excited state the probability is 2 by 3, right? Then I multiply this probability with the energy state
And
and
did you
then
put
find the
n plus
expectation
half
value
h
of
cut
each
omega?
state.
Did you put n plus half h cut omega?
Yeah, yes, ma'am.
For first state, it will be half h cut omega. The first second state, it will be. This is the ground state and the second excited state. So first excited state is psi 1, second is psi 2. So for the second, it will be n equal to 3, right? Did you put n equal to 3?
N equal to 2.
No, matlab, see, this is the ground state, right? For harmonic oscillator, this is psi 0 x.
Ground state
And
for
this is the first excited
yes for
state.
ground.
And this is the second excited state. Okay, for ground state, n is 0. So this is n equal to 1. This is n equal to 2.
Yes, ma'am.
So for this, it will be n equal to 2.
11 by 6. 11 by 6 we will get.
So this will be 5 by 2 h quart omega. And this is half h quart. Okay. Now you have to find out what is the expectation value of energy as a function of time. So expectation value is it normalized, this function? So first,
Yes,
psi
the
of x
wave
is
function is
normalized. It is normalized, and so it will be is nothing but it is 1 by 3 plus 2 Okay. So now I think I'm doing everything is okay, right? It is so it is okay. So I'm also not getting. I think I'm doing anyway wrong, or the answer is wrong. So let me clarify your doubt in the next session. Will it be okay? I think I'm
ma'am,
not
my
getting.
answer is 11 by 6.
हाँ. So size 0 size. Oh wait, 1 minute. Oh, is the screen is not visible? Didn't stop. Wait, my screen, why is not my screen visible? Is my screen visible to everyone?
No, ma'am.
Oh, it
No,
got
ma'am.
disconnected. Oh, wait. Minute. Why now? There was a problem. Why now? Okay, let me leave this session. I will rejoin, don't worry. But I think my screen is not able to connect. So let me leave now. Means uh, from both my application. I will rejoin, wait for some time.
Voice near.
I think your mic is off, so unmute yourself.
Hello.
Yes, ma'am. Now you are audible.
Okay, so I don't know. I'm not able to share my. So let me share here then in laptop. Is the basic. So you can follow Griffith or Jetli. Jetli is also there. Quantum mechanics concept and application. So you can follow that. For some reason, my screen got disconnected. So let me share here. Now you are seeing my screen, right?
Not yet, ma'am. Yes, ma'am. Now screen is visible.
Yes, ma'am. Visible.
Really, my tab screen is not visible. I don't know why. So, okay, Harish. So I will check and I will confirm the answer in the next section. Will it be okay? I think you are getting the
Okay,
right
ma'am.
value. 5 by it will be 5 by 3 only. Then why they're taking? I think I was up to here. So this is the I think this is the question you were asking about, right? This one, size 0, size 2 denotes.
Yes, ma'am. Yes, yes.
second excited state energy. So okay, I will confirm in the next class. I'm also getting the same one, but let let me confirm once from this NPTEL side. Let's move to the next question. You don't have any question now, right?
No, ma'am.
Okay, so let me continue. Sorry, I'm not able to connect my tab because of some internet issue. So let me just show whatever I've solved previously. So the third one is asking about what will be the value of a psi when you act a constant vector psi with phi is a with psi. So this is nothing but multiplying a constant vector a with the initial kate vector psi, which is given. Let me so I oh, there is no pointer here. Okay. So this is nothing but a times psi. So just put the constant value, which is 2 plus 3i. 2 plus 3i with the vector psi. One minute. Okay, now I think my screen is visible to you. So let me write it here. Wait for 2 minutes. So, okay. I will tell you about the book in the last. So, one book is there where you can understand it more clearly. So let me, it is already being late. So let me solve some more question. Harish, you have any query? You can ask in the last. I will ask you in the last. Okay. Screen is.
Ma'am, again, your screen is not
Is
visible.
so whoever have any doubt now, you can ask in the last section. I think for yours very
Excuse me, ma'am.
huh.
I have posted a answer for week 2 question 5 in the chat box.
Okay.
So if this question can help you.
But if it didn't, okay, let me share my screen first. Okay, what is I got so E2 is how you are getting 5/3. E0 is
Ma'am, to be honest, this is not my answer. I have not
okay.
written
Okay,
this answer.
this is the answer you in the site, right? NPTEL site. Okay, I will clarify the doubt of Harish or all of you in the next section. Let me solve some more question. So I think screen is visible. to everyone. So let's solve this
Yes, ma'am.
one. So now it is given some constant vector A is given. So now it is asking about what is the value of A psi. So A psi is nothing but multiplying a constant vector in the initial ket vector psi. Okay. So psi is given. Psi is, what is psi? So this is 3i plus phi 1 plus 2 phi 2 plus I phi 3. So if you want to, the constant vector is 3i. So you want to multiply this with the initial ket, then it's simply multiplication by a scalar. So I think you can get it. This is easy. 2 phi 2 plus 2 plus 3i phi 3. So just multiply with the factors and you can get what is the final. So be careful while multiplying a constant factor with a, if the question asks about this one, then this will be different. Like if you want to fact take out the constant vector from this bra notation, then you have to take the complex conjugate. Okay. So it is for ket vector, it is okay. You can write it as SI. But when you take the bra vector, then it will be SI star. So in that case, you have to take the complex conjugate of this constant, which is nothing but minus 2i. Okay. Okay, this one is things simple, and I think everyone can find out what will be the value of this one, like psi plus phi and psi minus phi. So this is nothing but psi plus phi and psi minus phi. So let me write the answers. Psi plus phi. Psi is 3i plus phi 1 plus 2 phi 2 plus psi phi 3 and 2 phi 1 minus 3 phi 2 plus 5 phi 3. So just add the terms, similar terms like phi 1 with phi 1, phi 2 with phi 2, phi 3 with phi 3. Then you can get 3i plus 2 phi 1 plus, I think it will be minus phi 2 plus 5 plus I phi 3. Okay, this is the final form. If you want to find out the expression for psi plus phi. So I think everyone can find out the next one, which is nothing but the subtraction of this with this. So I'm skipping this question. So let me go to the next one. So consider the ket vectors given below. Psi, this is given and this is given. So where phi I satisfies the condition, Kronecker delta condition. So now it is asking about compute the matrices corresponding to the kets psi and phi in that basis phi. So it is asking about asking to represent this expression that is given to you in terms of matrices. So matrices, what you do is you represent a ket vector with a column vector. Uh, you represent it as a column vector. So where psi can be written as C1, C2 and C3. So C1, C2, C3 are nothing but the inner product of this Ci. This is nothing but the inner product of 5i with psi. So this equation you can write it in terms of summation of Ci and some phi the in terms of linear combination of this orthonormal basis. So when you want to represent this state in terms of a matrices, so you just have to represent the gate vector in terms of a column vector and write the what is the coefficients c1, c2 and c3. So c1 you can write phi 1 with psi 1. So what will be the answer of this? Phi 1. So these phi I, phi j are orthonormal. Sorry, they are satisfying this condition. So this means cross terms will be 0. So that means if the cross terms is 0, then you have to take phi I with phi 1 with phi 1 only. So this means this is 3i and C2 is nothing but phi 2 with psi. So this will be 2 and C3 will be phi 3 with psi, which is nothing but I. So the final expression is 3i, 2 and I. Now if the next one, I think you can do 5. For 5 you can write it in terms of the column vector. So this will be 2 minus 3, 5. Okay, this is done. This is another simplest question. Now next move to the next one. So now it is asking, okay. So in a linear vector space equipped with an orthonormal basis phi 1, phi 2, phi 3, an operator A acts on this basis vector and the results are given. So what is given to us? It is given that phi I are orthonormal basis. These are orthonormal bases. And it is given that an operator A acts on this basis in this basis set and the result is A phi 1 equal to 2 phi 1, A phi 2 equal to 3 phi 1 minus I phi 3 and A phi 3 equal to minus of phi 2. This is given to you. Now it is asking to represent this operator in terms of the matrix. So similar to the gate vector in bra vector, you can also write a operator in terms of the matrices. So A is nothing but normally the general representation is A11, A12 up to, let's say it is n dimensional, A1, A1n, A21, A22, A2n. This will go around up to AN1 and this will come ANN. This capital A. So what are these this vector? These are nothing but A11 is simply phi 1, A phi 1. Similarly, A12 is phi 1, A phi 2 and A13 is phi 1, A, phi 3. So these are the expression. So now you are, if you are seeing that there are three orthonormal bases, that means the unit vector A will be a 3 cross 3 matrix, where the elements are A11, A12, A13, A21, A22, A23, and A31, A32, and A33. Okay, so just use this equations that is given. So if you want to find out A11, then you have to take A phi 1. Now this one is given to you. This one is given to you is 2 times phi 1. So that means this will become phi 1, 2 is here and phi 1. So this is simply 2, right? So similarly, let me A12 will be phi 1, A phi 2, which will be, this is given to you. So there will be no A here. If you find out phi 2 is, this is phi 1 and A phi 2 is 3 times of phi 1 minus I times of phi 3. Okay, so now if you multiply it, then this is phi 1, phi 1. This is I times phi 1, phi 3. Right? But this is 0 because these are orthonormal bases. So final answer is 3. So now if you do it this way, I'm not calculating all the coefficients, but I think you can do it. If you do it, A13 will come around 0, will be A21 will be 0 also, and A22 will be 0, and A31 will be 0. So the final expression that you will get is this one will be 2, 3, 0, 0, 0, minus 1 and 0. Just check this one whether you are getting or not. I think you will get, if you follow the procedure I have followed, then you will get this final form. So this is done. Now the next question is, so if okay, I want to tell you one thing to all of you. If you have any query regarding the problems that is given in the assignment, so first at least write in the discussion forum. So you will get a immediate answer there. Okay. So now for now I will go through whatever problem you are facing in the given assignment. Then I will tell you in the next in my next session. Okay. I think Harish is okay. Have you write it in the discussion forum regarding this? So at least write it there first. Okay, write it there. Take the screenshot and write whatever problems you are facing, and also attach the way you are getting different answer. Then you can get a prompt answer there. Okay, just write it in the discussion forum. Otherwise, I will also clarify the doubts. So let me finish the questions first. Now it is given psi is this and phi is this. Now you want to find out what is the value of this one. I think it's easy. So this is given. You have to just find out the what is the bra vector for this, which is nothing but the dagger of this operator, right? So this will become -1, 0, -I. Okay. So if you want to take the calculate this into 3I 4 -1, 0, -I. This will be nothing but -2, 0, -2I, -3I, 0, 3, 3, and -4, 0. So it will be -4I. This was one of the simplest question. Okay, so let me solve the last question, then I will.
मैम फिर से दिखाना एक बार.
Okay, this one.
Yes मैम.
हाँ.
Clear मैम.
Clear?
Yeah.
So let me solve the last question. I think this is no, there is another question. Okay. So it is asking about calculate the A dagger. A dagger, Hermish, which is nothing but the Hermitian conjugate the operator A, which is given by the matrix A. This is given to you and it is asking about find out the A dagger of this matrix. So I have taken some simplest questions so that you can so that the concept will be clear for you and you can proceed with the one which is asking. Like if now it is asking about the A dagger. So first we have to find out what how can you find out the A dagger of a given matrix. So A dagger is nothing but it can you can simply write A dagger is this, like the transpose of the matrix A and they take the complex conjugate. So if you want to find out the dagger of any operator, so first what you have to do, take the transpose of this matrix, then take the complex conjugate of this matrix. In that way you can find out what is the A dagger. And by and it is also asking about whether this is Hermitian or not. Why Hermitian? What is the condition for Hermitian? So if
A dagger बराबर है.
so if your operator is Hermitian, then A dagger will be equal. So A is given to you. These matrices are simple. You can easily find out what is the transpose. So first take the transpose. Transpose, the row vector will become column vector and column becomes row vector. So now this whole column will become a row here 500. This one will become the second row 0, 1, 2y. And the third one will be 0, -2y and -1. Now you have to take the complex conjugate of the this matrix. So by complex conjugate, you have to replace I with -I. So this will be 2I minus. So this is the final expression. So now if you compare this A dagger, this is nothing but A dagger. So this is equal to this one, right? So that means A equal to A dagger. So the given matrix is Hermitian. Okay, this is clear to you, I think. So let's see the last question.
मैम हर्मिशियन एडजॉइंट का मतलब क्या होता है?
Hermitian adjoint, like this means Hermitian adjoint. Like you are taking the dagger of a operator. This is the definition. Like you take the transpose and take the complex conjugate. That means this is the Hermitian conjugate of an operator. Like what we say na, for a Kate vector, if a Kate vector psi is given to you, then we say that the dual of this Kate vector is the bra vector psi, right? So these are dual conjugate of each other. Now, if in case of operator A, if it is satisfy this condition A equal to A dagger, if this condition is satisfied, then we say that these are Hermitian conjugate of this A. Hermitian conjugate of each other. In the next section, we'll see this Hermitian conjugate is of unique properties. Your doubt is clear, right?
Yes, ma'am.
Harish? Okay. So let me solve the last question. So read the question at least once. Read the question, everyone. I think Harish, we have another problem in the question. In another question, right? You have posted in the chat box.
Yes, ma'am.
Okay, I will solve it in the last. So let me solve you in the this question first. Okay. So what is given? Consider two quantum mechanical state given by the state this phi1 and psi1. What is given? Psi equal to phi by phi1 plus 2 phi 2. And the other one is chi minus I by root 3 phi1 plus root over of 2 by 3 phi 2. So now it is saying that these two vectors are complete and orthonormal basis. Okay, orthonormal basis means now everyone know what is the meaning of orthonormality. So this is nothing but this is delta Ij, which is equal to 1 when I equal to j and 0 when I not equal to j. So now it is asking check whether these vectors are projection operator or not. So projection operator, I think everyone knows now. Projection operators are nothing but it projects a state psi in one of the direction. So the properties of a projection operator are like if P is a projection operator, then the square of this projection operator will be equal to its initial value, like P equal to P square. And the another property is P is Hermitian. So P equal to P dagger. Okay, so these are the properties of a projection operator. So first, what you have to do is you have to check whether psi equal to psi square. Remember these properties. Okay, it will help you solve many problems. Properties are important. It will easy your process of solving. And the second one you have to check is psi equal to psi daggerism, whether this condition is satisfied or not. And similarly, you have to check it for the another gate psi. So let me solve it for the first one. And the next one you can, I think I will leave to you to solve. So psi is nothing but this is 5i phi 1 plus 2 phi 2, and this is minus 5i phi 1 plus 2. Okay, I have written it wrong. So this is the bra vector. So it will be minus 5i phi 1 plus 2 times of phi 2. Now just take the individual products. It will be 25 phi 1 phi 1 plus 10i phi 1 phi 2 minus 10i phi 2 phi 1 plus 4 phi 2 phi 2. So this is the final expression you are getting. So first, now you have to check whether you have to take the dagger. So dagger is nothing but you have to take the whole this expression dagger. So now if you solve it, the dagger of a real number is 25 only. So 5151 if you take, you have to find out the dagger of this one. Then minus 10i phi 1 phi 2 dagger minus 10i plus 10i phi 2 phi 1 dagger, and the last one is 4 phi 2 phi 1 phi 2 phi 2 dagger. So dagger, one of the property of a dagger operator is like if two states are given and you have to take the dagger operator, then this is nothing but B dagger, A dagger. Okay, so you have to use this property. So now you can write 5151 dagger is, it will be 5151, right? Like if 5151 dagger you want to find, right? So if you take is as A, take is B. So it will be B dagger plus A dagger. So B dagger is nothing but 51 dagger, which is A ket vector phi. Similarly, A dagger is sorry, this is A, right? First one. This is A. So your A dagger is phi 1 dagger. So this is nothing but the bra vector. So if you take the dagger of this initial one is same to the one that is that was there earlier. So now the next one, phi 1 phi 2 dagger. So it will become phi 2 phi 1. The ket will exchange their position because of this property. Okay. Now the next one is 10i phi 1 phi 2 and 4 phi 2 phi 2. Now if you compare this equation with the one what is here, then you can see that these are equal. This phi 1 phi 2 terms 10i is there. So phi 1 phi 2 10i is there. Phi 2 phi 1 minus 10i, here minus 10i. Here 4 is there, 25 is there. So this means these are Hermitian conjugate. Hermitian operator. So the first condition is satisfied. Now for the second condition, like this the square one. So psi, we have to check psi square is psi or not. So psi square, how can you write psi with psi. So you can simply write it as. Now you see what is the value you are getting for this one. So psi is given to you, right? This is the value of psi. Now if you want to find out psi, then it is nothing but what will you get? 4 plus 5i into minus 5i. So this is nothing but 4 minus 25 plus 25. So this is 29. So just put the value. It is 29. So this is 29 psi. So here you are seeing that this square is not equal. Square is not equal to psi. So that means one of the property is not satisfied. So this psi is not a projection operator. Okay. So I will leave to you to find out what will be the case for the next one. So if you follow the same process, like if just check whether the dagger is equal to the initial one or not, or square are not equal. Just check these two properties and you will see that this is a projection operator. Check. I am leaving to you. Check this will be a projection operator. You can find out this is a projection operator. Okay. So, okay, anyone have question? Any one of you have question? Harish has posted one question. Okay, so let me briefly told what will. This is the question. Phi 2 plus a phi 3 and 2 phi 4. The next one is psi 2. This is psi 1. It is 2 phi 1 minus 3i phi 2 plus 3 phi 3 minus phi 4. The numeric is a is a constant the value of a, so that psi and phi are orthogonal. Okay. So Harish, you are getting some different value, right?
Yes, ma'am. I think in the wave function, a should be negative. Then option will match.
A should be negative. So what is the answer you are getting? Minus 2i plus 4. So if I solve it,
2
let's
plus 7 iota by 3.
2 plus 7 iota by 3.
Yeah.
Oh, this is not here then.
Because in the option here minus 3 is given.
Okay. Okay, so if you have question in this, you have doubt in this question, then write it in the forum, discussion forum, okay? And also show your whole procedure. Means whatever the way you are followed the question, answer the question. Also set the file and ask whatever the problems you are having in the question.
वहाँ पे सॉल्यूशन मिल जाता क्या मैम?
A solution. They will post the solution also.
Yeah.
The NPTEL TA will they will post the solution. Anyone have any other doubts? If I solve, you can ask now. I will.
Ma'am, next time
Huh? Tell.
नेक्स्ट टाइम आप लैपटॉप का यूज करिएगा मैम, क्योंकि इसमें बाद में यूट्यूब पे अच्छे से नहीं दिखाई देता.
अच्छे से means quality is not good.
quality is
quality
not
is
good.
good, but
Even
the
we
screen
will
is
play
screen
If
is
you
720
slow.
change the
pixel.
quality now, you can get
No, ma'am. If we play with the 720 pixel, then also will not good. So I request to you, please use the
but
laptop.
in laptop what will happen now? I will not solve live. Like that will be a problem. That is is for everyone it is like that only?
And it is clearly visible to us.
Yeah. For you it is visible, right?
And it is clearly visible in the meeting.
In the meeting, the screen quality is good, but on the YouTube, quality is not.
Okay, I will check
So
then. If
why is
you
that?
if you change it to higher quality, then I think I have checked also. For me, it was fine. I don't know why it is.
Why
So
is
let
that?
me. Huh?
Why is that? Why is the case that the screen quality is low on the YouTube and now it is fine? Why is it so?
Okay, I have uploaded the higher quality video. So from my side, there will be no problem of getting higher quality video. I have checked also the video quality. Uh, can you check once again? Just change the quality. Okay,
Yes, ma'am. I
change
changed the
change the
quality.
quality to higher
Even
quality.
I was play this video with 720 pixel quality. Then it is not visible.
Okay. Okay, I will keep that in the mind. So let me first check whether my
If
way.
this screen recording is in the landscape mode, then it will easy to.
Okay, so let me check once again whatever video I've uploaded it, whether the quality is good or not. Otherwise, I will re-upload
Because
it.
half of the screen
Huh.
visible for this lecture, and half
Okay,
of
okay,
this. Yeah.
okay. I will check. I will keep that in mind. Otherwise, I will. Uh, so I will write down all my answers in the laptop and I will share the screen using laptop only. Anyone have other doubts? Otherwise, I will end the session. It's almost time.
Thank you, ma'am.
Okay. Okay. So I think no one has any doubt. So let's leave the section. Thank you everyone for joining the session. So let's see you on next Saturday. Thank you.